You know, the story of artificial intelligence, it's not really about robots or sci-fi. It's a story about people solving impossible problems. It's this incredible chain reaction that connects a secret code-breaking machine in World War II all the way to the phone or computer you're using this very second. So let's get into it. This is one heck of a story. And that's the big question, right? How in the world do you get from cracking Nazi codes to asking a chatbot for a recipe? It sounds like a crazy leap, but believe it or not, there's a direct line. And it all starts with one single urgent problem that had the fate of the entire world hanging in the balance. So here's our roadmap. We're going to trace this whole story through four major eras. We'll start in the 40s with the actual spark of computation, then jump to the 60s to hear the first real whispers of machine intelligence. Then we'll hit the 2010s for the AI Big Bang that changed literally everything. And finally, we'll land right here in the middle of a global race to build what's called artificial general intelligence. All right, picture this. It's 1939. The Nazis are using this incredible machine, the Enigma, to coordinate everything, especially their U-boat attacks. It's considered unbreakable. Why? Because it had quintillions of possible settings that changed every single day. Trying to crack it by hand was hopeless. So the Allies turned to a genius mathematician, Alan Turing. He realized you couldn't fight this machine with people. You had to invent a new kind of machine to fight the machine. And the machine Turing and his team built, well, it did more than just win the war. It was the very foundation of our entire digital world. This was it. This was the birth of the computer. But this amazing solution came with a massive, literally warehouse-sized problem. See, these first computers were absolute monsters. I mean, they took up entire rooms, powered by thousands of giant glass vacuum tubes that basically worked like light bulbs. They got hot, they burned out constantly, and you needed teams of people just to keep them running. They were totally impractical for, well, just about anything else. But a brilliant and pretty intense physicist named Bill Shockley knew there had to be a better way. And in 1947, Shockley's lab had its eureka moment. It was something called a semiconductor. You can think of it as a material that can be a perfect little electrical switch, on or off, 1 or 0. This little thing, the transistor, could replace those huge, clunky vacuum tubes. This was the invention that would shrink the future of computing from the size of a warehouse down to the size of your fingertip. So Shockley moves out to Palo Alto, what we now call Silicon Valley, starts a company, and puts together an absolute dream team of scientists. We're talking guys like Robert Noyce and Gordon Moore. But here's where the story gets good. Shockley was a genius, no doubt, but he was also a terrible, paranoid manager. Just a few months after he won the Nobel Prize for the transistor, 8 of his top guys had enough. They walked out and started their own company called Fairchild Semiconductor. Shockley was furious, calling them the traitorous 8. But it was their company that perfected the silicon transistor and went on to completely own the market. But with this massive success came the next huge, impossible problem. The military needed to guide missiles. Businesses wanted to run payroll. They needed computers with not just one transistor, but thousands of them. And each transistor could only do one tiny little job. The idea of wiring thousands of them together by hand, it was a logistical nightmare. The entire industry was about to collapse under its own weight, a problem they called the tyranny of numbers. The solution came from Robert Noyce, the leader of that traitorous 8. Now, to be fair, an engineer at another company had technically built an integrated circuit first, but it was this ugly, fragile mess of wires. Noyce's invention was different. It was clean, flat, and most importantly, it was designed to be mass-produced easily. It was the difference between a cool science fair project and a product that could change the world. It was a practical solution, not a one-off superhero gadget. And this incredible invention didn't just kickstart an industry. It created the very culture of Silicon Valley. Fairchild became this amazing incubator, but its employees kept leaving to start their own new companies. They became known as the Fairchildren. And just look at this legacy. It's staggering. Over 92% of the world's computing power today can be traced back to companies started by former Fairchild employees. Companies you've definitely heard of, like Intel, founded by Noyce himself, and its biggest rival, AMD. Okay, so while all this crazy hardware drama is unfolding, the idea of artificial intelligence is starting to bubble up on the software side. It really starts with Alan Turing again, asking that profound question, can machines think? Then, in the 50s, a pioneer named Marvin Minsky actually builds a primitive neural net. But the really wild moment came in 1966 with a program called Eliza. It was the world's first chatbot designed to act like a therapist. And it blew people's minds. People would pour their hearts out to it, completely convinced they were talking to a real empathetic person. For the very first time, it felt like a machine could understand us. Then we get another landmark moment, this time in 1997. IBM's supercomputer Deep Blue goes head-to-head with the world chess champion Garry Kasparov and wins. But the win itself isn't what's really important here. What's crucial is the formula IBM used to do it. Take a look. Large volumes of data, in this case, tons of chess games, a strong algorithm, and massive, massive compute power. Data, algorithms, and compute. I want you to burn that recipe into your brain because it is the blueprint for every single AI system we have today. So for years after Deep Blue, AI research was kind of simmering on the back burner. Neural networks were cool, but nobody could seem to really unlock their true power. And then 2012 happened. One moment, one competition changed everything. A moment so important, we now call it the Big Bang of modern AI. So the breakthrough came from a professor named Geoffrey Hinton, who we now call the godfather of AI, and two of his grad students. They entered an annual image recognition competition. And their AI model, which they called AlexNet, didn't just win, it annihilated the competition. It wasn't just a little bit better, it was a quantum leap better. And in that moment, it proved to the entire world that neural networks were, without a doubt, the future. So what was the secret sauce? Well, let's go back to that IBM recipe. Data, algorithm, compute. Hinton's team had the data from the competition and a brilliant new algorithm. But for the compute part, they did something clever. They used powerful graphics cards, GPUs, made by a company called Nvidia, which back then was pretty much just known for making video games look cool. This result was so world-shattering that Nvidia's CEO, Jensen Huang, famously bet the entire future of his company on AI. And looking at this chart, I'd say that was a pretty good bet. After this big bang, the race was officially on. Google immediately went on a shopping spree, buying Geoffrey Hinton's company and basically trying to hire every single AI expert on the planet. This made a lot of people in Silicon Valley really nervous, including Elon Musk. They were terrified of one giant, for-profit company having total control over this powerful new technology. So they banded together and created a counterforce, OpenAI, a nonprofit lab with a mission to build AI safely and for the benefit of everyone. And to kick things off, they needed top talent. So Elon Musk himself personally recruited one of Hinton's star students, a guy named Ilya Sutskever, poaching him directly from Google. This move apparently created a huge personal rift with Google's co-founder, Larry Page, and it really poured fuel on the fire of the competition between these two labs. Now, ironically, the next giant leap forward came from inside Google. In 2017, their researchers published a paper on a new model they called the transformer. Before this, AI models read text one word at a time, sequentially, almost like they were reading through a tiny straw. But the transformer could see the whole sentence, the whole paragraph, all at once. It could understand context and the relationship between words. This was the final, crucial piece of the puzzle, and it's the core technology inside every chatbot we use today. OpenAI saw the massive potential of the transformer and decided to go all in on building the biggest version the world had ever seen. But there was a problem. Remember the recipe? They needed an absolutely insane amount of compute power, and that cost a fortune. So they made a pivotal decision. They partnered with Microsoft for a $10 billion investment. This move, partnering with a massive for-profit company, clashed with their original nonprofit mission, and it's what ultimately led Elon Musk to leave the organization he helped create. So now, armed with Microsoft's money and mountains of compute, OpenAI took that transformer architecture, fed it a huge chunk of the internet, and in November 2022, they released it to the world. They called it ChatGPT. Its impact was just instantaneous and historic. It had 100 million users in 2 months, making it the fastest-growing app in the history of humanity. This was the moment the starting gun fired on the global age of generative AI. Which brings us, finally, to today. The explosion that started with ChatGPT has kicked off an investment arms race unlike anything we have ever seen. And the numbers being thrown around are just mind-boggling. We're not talking billions anymore. We're talking trillions. $7 trillion is reportedly the figure that companies like OpenAI are now trying to raise to build the next generation of chips and AI models.
So there you have it, from a secret machine built to win a war to a global technological revolution that is reshaping our world faster than we can keep up. We've seen how this entire history is just a series of impossible problems met by brilliant solutions. We've learned how we got here. The real question, the one we all have to face now, is who gets to decide where we go next?